everyone, welcome to SingularityComputers Client Build 12 Part 2. In this part of the build log, I'm going to complete both of the loops and bring the wiring close to completion. In the last video, I mentioned that I was going to start this part of the build log by taking you through cutting and bending acrylic tube. As you can see, I've started on the tubing, but there is still a lot of tubing to be done, and I wanted to take you through tubing up the more complex sections of the loop. But before I can move forward with the tubing, I need to install the rest of the water cooling components. I still need to install another radiator into the bottom compartment and also the pump and reservoir configurations. With some builds, there's a specific order in which the components need to be installed. And I'm not just talking about the obvious order in which you should install the components. I'm talking about builds where if you don't install the components in the correct order, you block access and can't move forward with the build. This happens more often when modding. With this build, for example, I'm going to need to install all of the components into the bottom compartment before I move on to the installation of the pump and res configs. And each component going into the bottom compartment will need to be installed in a specific order. I'm now considering where I'm going to install the pump and res configs because I wanted to install them side by side on the motherboard tray next to the motherboard, but it turns out they don't actually fit there. So the only real position I have left is side by side on the back of the hard drive cages, unless I want to go completely changing the case, which is not really part of this build. But if I'm going to install them in this position, I'm going to need to come up with some kind of a custom mounting system. I'm going to come back to this shortly. I'm now going to move on to installing all of the components into the bottom compartment. I'm changing the power supply in this build from the Seasonic X1250 to the EVGA Supernova Next 1500 watt classified. I'll talk about why coming up. So a brief look at the accessories and cables. The power cable is made from 12 gauge wire, so it's incredibly thick. It also has an extra large plug. Every part of this power supply is designed for extreme performance. The cables are individually sleeved, and some of them are sleeved in black, some of them in red. I'm impressed with the quality of the sleeving. Compared to the hard plastic sleeving that you often see, this sleeving is more like paracord. It's made from a finer, more densely woven, soft material. Just to give you an idea, this power supply has 16 8-pin or 6-pin PCIe connectors, which is just incredible. And this is not even all of the cables. I've actually removed some of them because I'm starting on the custom wiring and I'm using them to get my pinouts. So it's a great looking power supply. It's black and red with a black wrinkle coat finish, which is extremely durable. Looking at the basic specifications, in single rail mode the output is 1500 amps, 124 watts. In overclock mode, 1650 watts, 133 amps. It can also be split into 8 12-volt rails at 20 amps each, and it's 80 plus gold certified. It has a double ball bearing, quiet 120mm fan. Wherever you look, the aesthetics are excellent. You can see the ventilation to the fan is built into the power supply casing itself. Looking at the back of the power supply, it has plenty of honeycomb ventilation. You can see the extra large connector. It has a large high quality on-off switch and a chromed handle built into the back of the power supply. The power supply is fully modular, and you can see the USB connection on the back here. This allows you to monitor and control the power supply from within your operating system using EVGA software. So I'm looking forward to seeing how the power supply performs, and hopefully it has good pinouts for custom cables. So I've installed the power supply into the bottom compartment, and it's now time for me to install the 240mm radiator. The 240 I'm using matches the two radiators I already have installed. It's an EK XTX. The power supply was actually difficult to install. Usually the best way to install it in this case is to drop it down from above. But because I've already installed the graphics cards, it was an extremely tight fit, and it just goes to show what I've been saying about component order. I'm now preparing to do the custom wiring for the 6 radiator fans in the lower compartment. If I don't do it now, once I install the 240mm radiator, I'm not going to be able to get access. I also need to do a section of tubing that's going to run between the 480 and 240 in the bottom compartment, and I'm going to need to install that as I'm installing the 240mm radiator. You can see the drainage system that I've set up for the graphics card loop. As I've mentioned, the 480 and 240 in the bottom compartment is going to be for the graphics card loop. And this is just one of those things that worked out perfectly, and I'm really not used to that. I'm used to putting a lot of time, planning, and effort into everything. But thanks to the drain port on the EK-XTX, I was able to install the bits power valve into this position. I've connected it with a bits power mini D-plug, which is something I often do. It's a good fitting for the bits power valve because it's nice and short, it allows rotation, and it's also easy to dismantle. And you can see the config fits perfectly here. It fits inside the front dust filter and front panel. So very easy access from the front of the build. You just need to remove 2 panels, which takes seconds. And it's at the lowest point in the loop, which means it's going to work perfectly. Now the fan configuration I'm going for in this build is one that you'll often see me use. As I've mentioned, the fans I'm using in this build are Noiseblocker Black Silent Pro PL2s, and because they're quiet fans, I'm going to run them all at 100%. And I'm going to use Mod My Toys fan splitters. I often use these, the quality is excellent, I've never had any kind of a problem with them. They look great, the range is also excellent, which allows for so many different configurations. What I'm using in this build is Molex to 3-pin fan splitters. And for the 6 fans in the bottom compartment, I'm going to use 2 3-way splitters. For the top radiator, I'm going to use a single 5-way splitter, which is going to leave 1 3-pin fan header spare, which I'll probably end up using for lighting. I've installed the 2 3-way splitters, and I've completed the custom wiring for the 6 radiator fans in the bottom compartment. As you can see, I've installed the 2 splitters in the center of the bottom compartment. So this is going to be in between the 2 radiators. I was thinking about installing them behind the power supply where they're going to be easier to access and in view, but there's going to be no room for them there because that's obviously where all of the power supply cables come out. In this position, they are going to be a little bit difficult to access, but they're going to be completely hidden, so it's going to be incredibly clean. I've now installed the 240mm radiator, so all of the radiators and fans are now installed. And it was difficult to get into position because as I was installing it, I had to install a length of tube between the 480 and 240. So you can see this length of tube here, and looking from the front of the build, you can see it more easily. At the back, it connects to the 480, at the front to the 240. So at the back, I've used a 90-degree single rotary fitting. At the front, I've used another 90-degree single rotary fitting in combination with a 20mm extension fitting to line up the tube. So you can see the 2 fan splitters here, and it wasn't actually too difficult to access them to plug in the 2 fans on the 240mm radiator. I thought that was going to be a real problem, but the splitters are accessible from the top and front of the bottom compartment. So this radiator configuration fits perfectly in the 900D with plenty of room to spare. As you can see, there's a good gap between the 2 radiators of approximately 60mm. And considering these radiators are 64mm thick, it just shows the capabilities of this case. You would actually be able to fit 2 Alpha Cool Nexus Monster radiators, which are 80mm thick, side by side in the bottom compartment of this case. At this point, the 24-pin, all of the PCIe, and also the 8-pin EPS cables are complete. And I mentioned a few months ago that I actually have somebody employed now who does some of my cables. And he wanted another mention, so he's a retired electrician, so he has that experience up his sleeve, and he also has a strong interest in computers and modding, so a perfect person for the job, and he does an excellent job of my cables. Now, instead of modifying the existing power supply cables, which is still a perfectly good way of doing things, I always build power supply cables from the ground up with all new components, so new wire, pins, connectors, and sleeving. And this sleeving is MDPC black, heat shrinkless sleeving, as you can see. Another thing I do is use 16 gauge wire, which is usually an upgrade from the 18 gauge wire that is most often used. But we can also do sleeving with heat shrink, paracord, whatever is requested. I've now installed the 24-pin and both of the 8-pin EPS cables. I'm actually going to leave the rest of the wiring until I've completed and filled both of the loops, because the PCIe cables in particular are going to be in the way. You can see that I've used the ModSmart cable management clips that I often use in my builds. A lot of people ask about these, so I'll put a link in the video description to where you can get them from. So that's it for cables for now. Now I'm going to go to work on completing both of the loops. So the final components I need to install before I can complete the tubing is the pump and res configs. And I'm now building the custom mounting system to mount them to the back of the hard drive cages. If you take a look at the stock mounting system for the EK-D5 XRES 140, it's a great mounting system, and I'm actually going to remove part of this mounting system, but I'm still going to use the anti-vibration rubber mounts. And I think you can see from what I've done to this panel so far how I'm going to go about mounting the pump and res configs. Now this is my sheet metal bender, and I've had this for a few months now, and it's a great tool to have for modding. It really allows you to do a whole lot more. There's so much you can do with it. You can put multiple bends in panels, so you can even bend around a sheet into almost a box. I've put up to 3 bends in one panel and built a hard drive cage out of it. I've made all kinds of components so far. And you can actually pick these up on eBay, this particular bender, for less than $100. It's 800 millimeters wide, and it will bend up to 1.5 millimeter steel and even thicker aluminium. I've bent up to 2 millimeter aluminium, 600 millimeters wide without a problem. Now you need to purchase the G-clamps separately. You need to get at least 3. They need to be nice and strong. It puts a lot of pressure on them. And you really need to bolt the bender down to something strong. As you can see, I've bolted mine directly to concrete. So I'm now doing the first test fit, and you can now see how it all goes together. I've dropped the pumps down through the panel and mounted the pump and res configs using the anti-vibration rubber mounts. But those mounts weren't going to be enough. With the length of these reservoirs and the weight of these pump and res configs, they are surprisingly heavy, even heavier obviously once they're full of coolant. I also needed to mount them at the top. Now usually when I use these res mounts, I try to push them to the top of the reservoir tube so that all of the reservoir is visible, to improve the aesthetics. But in this case, I had to install the res mounts in this position because I needed them to be on the same panel that the pump and res configs are mounted to for strength, to hold the 90-degree angle in the panel. So I'm now doing the final test fit, and at this point I still need to get the mounting holes for the res mounts. Now the best way to get mounting holes is not to measure them out. If you do things that way, you're almost always going to get them in the wrong positions. You need to use what you're mounting the panel to as a template. So I've now painted the panel and it's ready to be installed. And you can see where all of the mounting holes are positioned. I've managed to mount the panel to the hard drive cages in 6 different places. So the strength there is also certainly not going to be a problem. You can see the finish I managed to get on the panel is similar to the finish of the case. I've also designed the mounting system so that it can all be assembled outside of the case. So first of all, the pump and res configs need to be installed, including the res mounts. Then the panel needs to be attached to the hard drive cages. And then the entire config slides into the case because the hard drive cages slide into the case from around the front. So I've now completed the final assembly. Now there's 2 hard drive cages, so I needed to be careful to position the mounting bolts, the 6 mounting bolts, as I've mentioned, for the panel, in such a way that they would hold the 2 hard drive cages together. And the way I've designed this, it actually massively improves the strength of the hard drive cages. The hard drive cages are held in position by 8 bolts around the back. You'll notice that there's approximately a 5mm gap between the panel and the hard drive cages. I actually put spaces in between because the surface of the side of the hard drive cages is uneven. So to mount the panel evenly, I needed to pack it out. I used nuts as spacers. Nuts are always a good thing to use as spacers depending on what you are doing because they act as lock nuts. So, it improves the strength, helps to hold the config together. You can see that I've sleeved all of the wiring at this point, but I haven't yet completed the sleeving because I don't know what lengths I need the wiring to be. To get those lengths, I would need to do a test fit, and that really takes a lot of time. So the best thing to do is just to sleeve the wiring, but leave the ends. I just cut the connectors off, leave the ends of the wires without pins, without connectors, and you can deal with that later once you get the wiring lengths. You'll notice I've used spaces between the panel and the res mounts. These spaces I've actually taken from a XSPC radiator mounting system for mounting radiators to the backs of cases, and they're actually a hard plastic. You'll notice that the pump and res configs are not centered between the top and bottom of the case. They're far closer to the bottom of the case. But if you take a look, the reservoir tubes themselves are centered. The reason I've done this is because once the loops are full, the reservoirs are going to be, the colored sections because of the coolant, whereas the surroundings are just going to be black. The pumps are black, the pump tops are black, so that all blends in, but the reservoir tubes stick out, and if they are centered, it makes the configs look centered, so it improves the overall aesthetics. I'm now about to install the SSD and hard drive. This is the only storage going into this build, and this is actually from the old build. So I have here a Western Digital Green 1TB hard drive and a SanDisk 256GB SSD. Those of you that have seen a lot of my builds will know that I almost never install optical drives, and I certainly never install them into my own builds because I only ever use an optical drive maybe once or twice a year, so I prefer to have an external optical drive. But one was requested for this build, so I've painted it black. Obviously it's a big improvement and it's going to blend in nicely. I can now complete the tubing for both of the loops, so at last I can take you through cutting and bending acrylic tube. I have 4 more sections of acrylic tube to install, so instead of doing a straightforward guide, I'm going to take you through the process of installing these sections. Now this is something I've talked about many times. When you're building a loop, the first thing you should do is install the core water cooling components, so radiators, pumps, reservoirs. After that, you need to come up with your component order and tubing routing. So first of all, your component order. Now, the less tubing you have, the cleaner the loop is going to look. So if you come up with the component order that gives you the shortest possible tubing routing, that is how to get the cleanest possible loop. So this takes a fair bit of planning and time depending on the complexity of the loop. When you're coming up with your tubing routing, with hard tubing, that is when you can, vaguely plan out the bends in the tubing and decide whether you're going to use fittings to get these bends or, bend the tubing, or a combination of the two. Now with soft tubing, it doesn't matter whether you install, the fittings as you go, some fittings, some tubing, but with hard tubing, you really should have all of the fittings installed first. And you can see I have the last of the fittings installed here ready to go, and I even have them angled. So everything is planned out. The only thing I need to do now is measure up the sections of tube, cut them and bend them. Now this is an EK acrylic tube cutting and bending kit. It doesn't have everything you need. I'm going to take you through all of the tools you will need for cutting and bending acrylic tube as we go. Monsoon has just released an acrylic tube cutting and bending kit with everything you could possibly dream of, and I'm going to do a video on this coming up soon, and that's what I'll probably be using in the near future. But with the EK kit you get a junior hacksaw, which is a great tool for cutting acrylic tube. You should really be using hand tools. I've tried a number of power tools, but they just make a mess of the cuts. Acrylic tube is quick and easy to cut, so yeah, the best way to cut it is certainly with hand tools. Most importantly, you get these 2 silicon cords, one of them 10mm in diameter, the other one 12mm in diameter. And you really should not bend acrylic tube without something like this, because you're just going to make a mess of the bends. These are absolutely critical for bending acrylic tube. And you also get a piece of 220 grit wet and dry sandpaper. I'm now going to briefly take you through the measurements of the different acrylic tube systems which are currently available from the different companies. Now when I say acrylic tube system, I mean the acrylic tube and fittings to come with it. So first of all, the original Bitspower Crystal Link, also E22 and EK at 10mm internal diameter, 12mm external diameter. Then we have Primo Chill at 10mm internal and 14mm external, and EK at 12 millimeters internal and 16 millimeters external diameter. The first tube I'm going to do here is probably the most difficult one in both of the loops. It's in a tight spot up against the motherboard tray, and it's the longest tube in both of the loops at 550 millimeters, which is longer than the 500 millimeter lengths that this EK acrylic tube comes in, which means I'm going to have to use an extension fitting. But it turns out that half of this section of tube is going to be out of sight up behind the radiator, so I can hide the extension fitting. So obviously I've measured the length of tube that I need, and I've also measured out where I need the bend to be. I need a 90-degree bend in this tube. And I'm going to take you through how I get these measurements shortly. I couldn't with this tube because it's in a difficult position. And I've now inserted the 12 millimeter silicon cord. I'm using the 12 millimeter cord because the internal diameter of this acrylic tube is 12 millimeters. And I'm using the ruler on my ModSmart mat that I have on my workbench to get the measurement for the bend. And I've just used my thumb and finger to get that measurement. And I'm now heating the acrylic tube. And I'm heating a small section of the tube because I want a tight bend. If you want a more gradual bend, you just heat a larger section of the tube. And you really need to use a heat gun. You're not going to get away with using a hairdryer. You need to use something that puts out a lot of heat. And it takes about 2.5 minutes to get this tube, this particular tube, to the temperature it needs to be at to start to bend. But it depends on the tube, the wall thickness. This tube has a 2 millimeter wall thickness, but if you're using Crystal Link or E22, it's going to heat up a whole lot quicker because it has a 1 millimeter wall thickness. And what I do, instead of continuing to check if the tube is hot enough, I just heat it until it starts to sag slightly. You need to be careful that you don't burn the acrylic tube because it ruins it. It ruins the surface. It discolors, bubbles, loses its shape, it ripples. It's really easy to see when you've burned it. And I'm now bending the acrylic tube gradually to a 90-degree bend. And it will want to spring back, so you need to hold it in position until it cools down. Removing the silicon cord can be really difficult, mainly if you have a complex section of tube with multiple bends in it and tight bends. And I've seen some people use vegetable oil and similar products to make it easier to push the silicon cord in and remove it. But I don't recommend this, because of the risk of contaminating your loop. I mean, you could remove it with metho or something similar, but still it's a big risk to take. The silicon cord, I've found, can still be removed. You just need to apply a lot of pressure, but the silicon cord is durable, so it can certainly handle that pressure. I now need to round off the ends of the acrylic tube. It doesn't matter which order you cut, bend, and round off the ends of the tube in. I just do it in the order that is easiest, depending on the section of tube I'm making. You can see that I'm masking off the ends of the tube and leaving approximately a 5 millimeter section of tube exposed on either end. Obviously, I'm doing this to protect the tube while I'm rounding off the ends. It's very easy to slip with the sandpaper and mark the tube where it's going to be inside. Basically, if you mark the tube outside of where the fitting is going to be covering it, it's very ugly. It's really obvious what has happened, and it just looks really sloppy. So mask off the tube. It makes it a lot easier. And the sandpaper I'm using here is 180 grit. It's good to start with anything around 200 grit, and I always go back to at least approximately 600 grit. The only time I will polish the ends of the tube is if I'm using Bits Power multi-link fittings. The smaller fittings, there's less margin of error, particularly the single O-ring fittings. Very minimal margin of error. It's a good idea to polish the ends of the tube if you're using those fittings to reduce the risk of leaks. I'm now cleaning out the insides of the tube, and you can do this with a sharp knife, a Stanley knife or something similar. And this is important to remove the loose acrylic inside of the tube, mainly after you've cut it. There's always a lot in there, and you definitely don't want that in your loop. Once I've completed cutting, bending, and rounding off the ends of the tube, I always give the inside of the tube a good wash under a high pressure tap. I run water through the tube to remove all of the loose acrylic from the inside. Now, during the process of making the tube, it's highly likely that you've marked it to some extent. So it's a good idea to polish the tube, and what I use for this is Novus acrylic polish. And that way it comes up like new. Often if you miss marks on the tube, you can see them later on when the coolant is in the loop and the lighting is installed. So it's a good idea to get it before you install the tubing. So that tube is now in position, and it turns out I had to put another couple of bends in it and put a 10mm offset in it to make it parallel to the motherboard tray because the radiator was holding it on an angle. Now this is how I get my tubing lengths. I use the silicon cord and push it into the exact routing that I'm going to be running the tubing. I then mark off the length with my thumb and finger and lay the silicon cord down next to a ruler. And this way I've managed to get the exact tubing lengths every time, so it works really well, and it's also a good way of visualizing your bends. So I'm now marking off the length on the acrylic tube, and I roughly get the length and then mask up the acrylic tube, and then I use the masking tape to mark off my length. And I mainly do this to protect the tube because I find whatever you use to cut the tube with, it almost always bounces around and marks up the tube. So what I'm doing here now is working on the last 3 tubes. I'm going to cut them to length and round off the ends all at the same time, and then I'll move on to working on the bends. Now, I've shown you how to do all of this with the bare minimum of tools. Obviously, if you have the right tools, it's going to make things a lot faster. And what I have here is a belt and disc sander, and I'm using the belt sander to round off the ends, which literally takes seconds. So the last 3 sections of tube are ready to be bent and installed. So when it comes to planning every aspect of my acrylic tube, the measurements, positioning of the bends, the angles, I use the silicon cord. And this is how I get the positioning for my bends. Again, I fit the silicon cord into position. As you can see, I'm pushing it into the fitting to get the exact measurements. And I mark off with my finger and thumb exactly where the bend needs to be. In this case, it needs to be a 90-degree bend. And this particular section of tube also needs a 10mm offset. And there's a couple of ways of getting an offset. You can put it in the same place as the initial bend, which is just a matter of twisting the tube, and that's actually what I've done here. Or you can put it away from the initial bend on either side. Now, probably the best tip I can give you for bending acrylic tube is to heat it to the correct temperature, because if you do, it's so incredibly pliable and easy to deal with. If it's not hot enough, you're going to get flat spots on the outside of the bend and kinks on the inside, and it will be difficult to bend. And if it's too hot, you're going to burn the acrylic tube, which is highly evident. It looks terrible. Now, I actually ran out of acrylic tube for this last section. The section I had left was about 3mm too short, so I'm going to have to wait for some more acrylic tube to arrive before I can finish the second loop. Anyway, that sums up this part of the build log. Thanks for watching. Please subscribe, like, and favorite if you want to see more.